Okay, hi everybody. Okay, let me to share screen first. Okay. Hi everyone. So today I want to continue my physics lessons. There's a Archimedes principle. There's a part two because the part one we still got so many about the buoyant force and also the Archimedes principle. So now we go to part two. This the talking about the Archimedes principle also, but this one situation is when the object is floating. Okay, let I go to share my screen first. Okay, now we go and see the screen. Okay, I go to change to full screen first. Okay. Uh, okay, so to the topics I just show here, there's Archimedes principle. So hopefully you know how to spelling about this word. There's after the S, there's a apostrophes. Okay, then we go through what is this. Okay, first one you can see the diagram. The diagram got one of the bottle. There's a floating. Okay, this one citation there's a floating. Now we need to state about the flotation of an object in the fluid. Okay, before that fluid I explained already. The fluid is either there's a liquid, either there's a gas. They also can be related to the Archimedes principle. Okay, now we go through the explanation again when the object is submerged in the fluid. So we don't care the object is submerged in the water or they submerged in the air. The object they will experiences two forces. Okay, I think every student will know what means of the two forces. Okay, two forces. First one sure will acting to the upwards. Okay, the upward we call it as a buoyant force. Okay, another one sure should be the weight. Okay, the weight of the object is always acting to the downwards. So when the question asks you to label, so you must label in opposite direction and also give the name. Up is a buoyant force and down should be the weight of the object. Okay, we continue to see the three situation for the object is floating. Okay, first one, you can see this diagram. These two situation we also call there's a floating. Okay, the first one is floating exactly the surface. Okay, another one is floating, there's a half. Okay, the half volume of the object already in the water. Another half is still on the air. Okay, so from here, the first one we can say volume object equal volume liquid display. But the second one, we cannot say volume object equal to volume liquid display because this one volume just halfway. I just can say volume object is more than volume of liquid display. So both also is a floating. Just the volume submerged in the water is a different. Okay, now they say floating stationary. Every student will know stationary means balance. Okay, what and what should be balanced? Should be the buoyant force balanced with the weight. So from here we can write the equation. W must be equal to the buoyant force. Okay, how about the resultant force? When I say stationary, resultant force sure is a zero. So the conclusion I can make it, this one situation, we call it as a balance force. Okay, so this is the first one when floating stationary. Okay, then we go to second situation. Okay, second situation, you find it, the a block, they will go downwards. So from here, they say the object move downward with an acceleration. Okay, they will go deeper and deeper with the certain acceleration. So just like this diagram, okay, the one of the block, they will go down. Okay, go down until to the base. So with the some acceleration. So from here, we can say which one should be bigger. Sure is a weight because you go downward, is it? So from here, we can mention W is more than the buoyant force. Okay, how about the resultant force? The resultant force cannot become zero already because you got acceleration. So from here, the resultant force is go downwards. The resultant forces must move the object go to downwards. So for this one situation, we call it as an unbalanced force. Okay, so we got the force acting to downwards. Okay, the block will go down with acceleration. Now we opposite. Now is the block go upwards with acceleration. Okay, let's see the diagram. Okay, now is the block. When they just drop, okay, they go downward. After that, they move up. So that means they move upward with acceleration. So now, sure, the upper force is bigger. So that's why the block can move upwards. So upper force is what? There's a buoyant force. Now the buoyant force is bigger than the weight. Okay, how about the resultant force? The resultant force now is acting upwards. Okay, so this one situation we also can call it as a unbalanced force. Okay, so understand for three situation. First one stationary. Number two is sinking, the sink. Number three is floating up. Okay, on the way they up. So this one is a three different things about the buoyant force and also the weight. So for this one situation, we need to learn is a equal W equal FP. Okay, when there's a floating stationary. Okay, now this one we call it force in equilibrium. Equilibrium means balance. Now the boat, okay, we can say about the ship. Now the ship there's a stationary, okay, on the surface of the sea. So you find it we got two forces acting to this one ship. There's a buoyant force and weight of the ship. So for this one situation, if they say there's an equilibrium forces, means there's a balance. Resultant force equals zero. Okay, when the resultant force equal to the zero, what we can conclude about this situation? Okay, let's see here. Okay, the resultant force on the ship, there's a zero. Weight of the ship, that will equal to the buoyant force. Okay, so we continue again. Follow for Archimedes principle. Okay, remember the Archimedes principle we learned before. Buoyant force, there's a equal to the weight of water display. Okay, this one is an Archimedes principle. So from here, I can conclude these two sentences. Okay, we can conclude weight of the ship actually equal to the weight of water display. Okay, because they're equal to buoyant force, so I can conclude the weight of this one shape actually they're equal to the weight of water display. So I show the equation. Okay, so therefore, weight of the ship, this one the weight of the ship equal to the weight of water display. But they got the rules. The rules is what? When the object is floating. Okay, we only can say weight of the shape equal weight of water display when the object is floating. Okay, when the object is sinking, we cannot say like that because weight of the ship should be higher when they sink. Okay, for this one situation, there's a floating, so we can say the three equation together. Buoyant force, weight of the ship, and also weight of liquid display, all equal. Okay, then we go and see force in equilibrium. So example for the block just floating. Okay, this one is a part that immerse in the water. So this one same lah. This one is a volume of water display. So from here you can write volume of the water display equal to the volume of the section the block immerse in the water. So this one is a VL. Okay, this one whole thing is a VO, but now the VL equal to the part that's submerged only, not whole VL, just only the part volume of the object immersed in the liquid. So from here, this one also the situation when the object is floating. Okay, this one is some example for the force in equilibrium. Okay, you got float, a man sit on the float, now just floating. So what equation I can create? The equation is weight of water display equal to buoyant force and also equal to the weight of the buoy plus the weight of the float. Okay, another situation also is iceberg. They are floating. So from here, three equation we can write. Weight of water display equal to buoyant force and also equal to the weight of the iceberg. Okay, so remember three equation we can move equal when the object is floating equilibrium. Okay, now application by using Archimedes principle in our daily life. The first one should be the hydrometer. Okay, we're going to see hydrometer actually what's the function. They want to measure the density of the liquid. Okay, now you can see the two diagram. Okay, the first liquid, when I just put the hydrometer, you can see the hydrometer sink. Okay, when the hydrometer sink means what? Means the liquid is a less dense. Liquid less than, hydrometer become denser. So they sink deeper, is it? When they sink deeper, okay, now they show the reading. You can see the stem. This one we call stem. Stem of the hydrometer, the reading at the top should be the less. Okay, then the bottom one should be the highest reading. So that means when I want to measure this liquid, what is the density? The hydrometer sink, is it? When it just sink, they show the reading should be smaller. Okay, smaller means this one density is a less dense. Okay, now the situation, I go to denser liquid. Example, this one is a mercury. Okay, mercury is sure it become denser lah. So mercury is a denser. When hydrometer put in, hydrometer is a less dense. So the hydrometer will be floating. Okay, when it just flow, you find it, the reading must show at the bottom one. So the bottom reading should be the highest. So from here, they can measure this one liquid high density. Okay, so remember the hydrometer, the stem, at the top should be the low readings. At the bottom must be the high readings. Okay, so from here, they got mentioned for you. This one is a low density. This one is a high density liquid. Okay, now we see the explanation. In a less dense liquid, example, this one is a less dense liquid, a larger section of the hydrometer is immersed. So you can find the big area. Okay, the hydrometer already immersed in the liquid. So why? To display a large volume of the liquid and vice versa. So that means when it sink deeper, more volume will come out. More volume to come out means V rho G, the whole situation, the volume should be increased. Okay, then depend the density of the liquid. Okay, if the liquid is more denser, that means the hydrometer will be floating. If the liquid is less than, the hydrometer will sink deeper. Okay, so this one is one of the application we're using Archimedes principle. There's a hydrometer. Okay, now we go to answer some of the question. Okay, now hydrometer. Okay, first one, what's the function for hydrometer? Just now we show you already. Hydrometer, they want to measure the density of the liquid. So from here, there's measure density of the liquid. Okay, number two, what's the function for the lead chute? Okay, the lead chute normally they put at the bottom. Okay, lead is more heavier. Important, they want to make the hydrometer will stand vertically up. Okay, do not overturn. So the answer from here should be hydrometer float vertically upwards. Okay, how about number three? Why does the size of the A-filled glass bulb must be larger? Okay, now you see the bulb, there's a big size that emerge in the liquid. When it just emerge in the liquid means the volume display must be higher, is it? So that means if I make the bulb become smaller, your volume display become less. When the volume display become less, buoyant force become less. So they cannot support the hydrometer. So now the situation, we need to create bigger, larger for the buoyant force. So I need to create bigger size of the bulb. Okay, now they explain for you. Create a larger buoyant force because they display more volume. Okay, and the last one, why the glass stem is thin and also longer. Okay, the glass stem you need to design as a thinner and longer. That's why they can show smallest reading of the division. The scale, they can make it become smallest. So the scale smallest actually what's the benefit? They can increase the sensitivity of the readings. Okay, so from here, more changes, a little bit changes for density they can detect it. So this one we call it there's an increase the sensitivity of the readings. Okay, so this one is a sum of the characteristic of the hydrometer. Okay, I see here, yeah, Yiru is here. Hi, Yiru. Okay, we continue with the next application. Okay, hydrometer again. Now they let you to compare the two situations. We got liquid A and also the liquid B. Okay, first one you can see the hydrometer should be the same. When I put in the liquid A, the hydrometer float. Okay, when I put into the liquid B, they also float, but sink a little bit. Okay, for this situation, both also floating. Just some is float higher, some is float less. Okay, so from here we just see the diagram. We go and see the comparison. Okay, liquid A sure is a denser liquid. Okay, denser liquid. So that's why the hydrometer can flow up. Okay, liquid B sure less dense. So that's why the same hydrometer will sink deeper. Okay, so this one is a what conclusion we go to understand lah. Because the reading, you see, the reading bottom of the hydrometer, this one is a bit. Okay, if higher a bit means the reading should be the less. Okay, so this one is a scale of the hydrometer. So the first one, they call you to compare the buoyant force in the liquid A and liquid B. Okay, buoyant force. For this one situation, remind back, I call you three equation when the object is floating. Okay, what's the three equation? Weight object equal to the weight of liquid display and also equal to the buoyant force. Okay, now the question they ask buoyant force. Okay, A and B, the hydrometer is the same. So that means the weight of the hydrometer equal to the buoyant force. Agree? This one is a floating, when the object is floating. So I can say now A and B, the buoyant force should be the same. Okay, so we just write buoyant force, both have the equal buoyant force because the weight of the hydrometer is equal. Okay, this one we just can say when there's a floating. Okay, the second one we go to explain. Weight of the object equal to buoyant force as the object is floating. Okay, important is floating. Okay, then we go to number 2. Okay, they ask you what will happen to the hydrometer when it's put into the liquid is less denser. Okay, if the liquid is less than means what? The hydrometer will sink deeper, is it? When it sink deeper, that means they'll show the reading become less. So from here, the question asks, what happened for the hydrometer? So we just answer, okay, the hydrometer will display more water, means they will sink. Okay, they will sink, go downwards more. Compare the density A and B. So A should be denser, B is less dense. Okay, A is denser. Okay, so this one is how to answer the question about the hydrometer. Okay, then we still got the principle of the Cartesian. They're also talking about the Archimedes principle and also the flotation. Okay, let's see the test tube. They float in the surface of the water. Then after that, the water in the test tube. Okay, they got halfway water in the test tube, but inside still got trap A. Now you can see the test tube, there's a floating. Okay, floating up. So when you see the explanation, when the test tube is floating on the surface of the water, the total weight, okay, total weight of the test tube and also weight of the water, and don't forget we still got trap A, so also total weight of the trap A, that's equal to the buoyant force. Okay, that means we assume the whole test tube they are floating stationary. Okay, at the surface, at the top. So from here we can make a conclusion. Weight test tube, weight water in the test tube and trap A, they will equal to buoyant force. Okay, let's see the second situation. Okay, second situation, now test tube, you go to press. Okay, whole bottle, you go to press it. Okay, when I just press it, you see what happened. As the pressure exert on the wall of the bottle, that means you go to press the bottle, water to be forced, okay, push into the test tube. So all the water they will trap in the test tube. Now the trap A become less. Okay, the water already replaced the trap A. So from here you find it, the test tube go downwards. Okay, the test tube go downward means now the weight is more higher than the buoyant force. So conclusion, weight of the water in the test tube now is increasing. Okay, then total weight of the test tube and also weight of the water in the test tube now is more than the buoyant force. So that's why the test tube will be sink. Okay, just now is equal because they're floating. Now you find the test tube go downwards, means the weight is higher already. Okay, then we go through resultant force acting downwards. Okay, because of total weight is higher. Then finally, they will create one of the force acting the object go downwards. So different force, we call it as a resultant force. Okay, submarine, they're using the same concept, just like the Cartesian just now. Okay, submarine, they got ballast tank. Okay, ballast tank actually was a function. They just let the water go in. Okay, why they need the water go in and water remove? Important, the submarine, they want sink and also they want float. How to sink? You must create the weight become higher than the buoyant force. So that's why the submarine can be sink. How to make the submarine go to float? So you must remove the A comma from the ballast tank to make the submarine become less dense compared to buoyant force. So the submarine can be lifted up. Okay, let's see the explanation for the submarine, how to move it. When filled with the water, the weight is bigger, so the submarine they will sink. When the water just removed, buoyant force now is a bigger, then the weight is bigger than the weight, then the submarine will rises up. Okay, this one is a ballast tank. Control the position and also the depth of the submarine in the water by controlling the quantity of the water filled. So that means they control the water, how many they want to fill in the ballast tank. That means they can control the position of the submarine. Okay, so this one is a function of the ballast tank in the submarine. Okay, we're still using the buoyant force and also the weight. Okay, Plimsoll line. Plimsoll line is one of the label that at the body of the ship. Example, they call label AB. AB stand for American Bureau of the Shipping. Okay, TF, they got tropical fresh water. Okay, F means the fresh water. So this one label, actually they want to prevent the whole ship that will overload. Okay, they need to remind the level, the maximum level for the boat when they just travel to the different country. Okay, different weather, climate, they also will changes the density of the liquid. So from here, they got one of the Plimsoll line to remind, okay, to remind them how many load you want to put in. So the first one, they ask you, what's the purpose? They can put the Plimsoll line mark on the shape. Okay, the answer is we need to help to determine the safe level for the ship to be float. Okay, what is the maximum level to let the boat can be floating? Okay, number two, why the line at different level? Okay, you can see got so many different level. Why? Okay, because of the density changes. Why the density of the seawater will change? Because of temperature. The temperature of the seawater, they will different so that the density of the seawater varies with the location. Different location, maybe you find the climate changes, maybe it's a summer, maybe it's a winter. So when this one temperature changes, they will affect the density of the liquid. So that means this one Plimsoll line, they just want to guide, okay, guide the passenger, guide the all the load put inside the ship must be in safety level. Okay, number three is a hot air balloon. Hot air balloon is a one, also is a Archimedes principle, but this one is not related with the water, but there's a air. Okay, we still can say there's a fluid. So from here we got two forces also acting to the balloon. So everybody also knows, sure, one is a buoyant force, another one should be the weight. Okay, compare the density of the A in the balloon and A outside. So when the balloon up, normally inside the density must be low. Outside is denser. So that's why the hot air balloon can be lifted up. So from here the answer is density of the A in the balloon is lower. Give two methods that have been done to the A inside the balloon to make sure the balloon can be rises up. So that means how to create the gas, or you say the A in the hot air balloon become less dense. So first one, sure, we go to heat it. Okay, we heat the gas, so the gas become hot. hot gas is a less than the cool gas. So from here, the first one, you go to heat up. Heat the air in the balloon. Okay, number two, you increase the size of the hot air balloon. When you just increase the size of the balloon, that means they trap more air. Trap more air, that means they can increase the buoyant force. So they can lift higher. So this one's a two method lah, how to make the ball can be rises up. Okay, we continue to number 4. Give reason why the size of the balloon must be big. I just now told you already. The size must be big means they can trap more air. When they trap more air means the volume become higher. Volume become higher, understood. The volume of liquid sorry, this one not liquid, this one is a gas. So when the trap air in the big hot air balloon, that means the volume of the air also increases. So when the volume of the air increases, follow the formula V rho G. So whole buoyant force they will increase. So that's why we need the hot air balloon go upper a little bit, rises up more. So from here, the reason is volume of the display air increases when the balloon is big enough. So the buoyant force will also increase. Okay, number 5, what will happen to the balloon if the buoyant force more than the weight of the balloon? So everybody understood, up is more than the down. Sure, that rises up lah, is it? So the answer is rise up. Okay, what will happen to the balloon if the buoyant force equal to the total weight of the balloon? So both equal means balance already. So this one situation, you find it the hot air balloon is stationary at that level. So the answer is the balloon float stationary. Okay, so this one is a sum comparison for the buoyant force and also the weight. Okay, so from here we can make a conclusion. When the object is float, okay, when the object is in the fluid, means in the liquid. So what equation we can create? This one is the Archimedes principle. Okay, buoyant force equal weight of liquid display, or you can say FB equal V rho G. Okay, number 2 is when the object is floating. Okay, floating. So that means we need to add one more equation. Okay, the equation is a buoyant force equal to the weight object and also weight of fluid display. Okay, so remember is this one. When floating, you need to add weight of object. Okay, so this one is what I want to present about the Archimedes principle when they are floating. So remember, when they are floating, you must including the weight of the object. Okay, so the following should be the formative 2.5. So this one later I will combine 2.4 until 2.6, the formative practice I will present here. Okay, I will show in my channel. So hopefully you like it and also subscribe my channel. Okay, so from here, our lesson just until this part lah. Okay, after I finish all the Archimedes principle. Okay, so the coming soon should be the Bernoulli principle. There's a 2.6, the last one from this topic. Okay, hopefully you can join. You can follow my physics channel here. Okay, so our lesson just until here. That's a bye. Thank you for your watching.